Find the domain and range of the functions. For number 5, f of x is equal to 2 over 3x minus 1. So if you have a rational function, the only part that must be taken out, or it's out of your domain or out of the area that is covered for x, or the values of x that is not acceptable, is what makes the denominator 0. So 3x minus 1, I let it equal to 0, and I say whatever x makes the denominator 0 must be taken out of the domain. So you add 1, or you take 1 to the other side. 3x is 1, so you divide both sides by 3. X equals to 1/3. So x equal to 1/3 should be out of the domain here. So if you have a number line, everything would be acceptable except 1/3. So anything outside of 1/3 should be okay. So the domain would be negative infinity to 1/3. You use parentheses because 1/3 is not included. And then 1/3 all the way to positive infinity. And that's the domain. Now you want to find the range. To find the range, if you think about this as a rational function, and on the numerator you have 2, so the only piece that is out of the range, so if you were thinking of projection along y-axis of the graph, is where you have the horizontal asymptote. So we need to take the horizontal asymptote out. And the horizontal asymptote, we say as x gets larger and larger, we want to know what happens to the value of y. So in this case, as x gets larger and larger, as x gets very large, so 3 times x gets very large, 3x minus 1 gets very large, 2 over a very, very large number is going to be about 0. So all you need to take out of this one is 0. So everything is okay for the range except 0. So that would be negative infinity all the way to 0, union with 0 to positive infinity. Okay. Question number 7. It says find the domain and range of ln, so h of x is equal to ln of x plus 6. So in order to find the domain of this one, we always say inside ln must be greater than 0, not equal to 0, just strictly greater than 0. So x plus 6 is greater than 0. With any log functions, inside the log, input of the log must be positive. So then from here, you subtract 6 from both sides. X is greater than negative 6. So then we have 0. We have negative 6. X greater than negative 6 would be this. Writing the interval notation is negative 6 all the way to positive infinity. This is an ln function if you think about it. So the graph of, I want you to be familiar with the rough graph of basic functions like ln or log. So in this case, your function is starting from negative 6. So that means your axis, probably the x-axis is somewhere here. And y-axis is somewhere here. And then x-axis is this one. and this is -6 to be your vertical asymptote. So basically, the reflection of your graph along x-axis is after -6. But the output of ln, if you think of range as projection along y-axis, it's going to cover everything. So it's going to be from -infinity all the way to +infinity. So that would be the range is going to be -infinity, comma, +infinity. Okay. Now use transformation to sketch the graph of the function. So let's just start with the basic of the function. So f of x equal to x cubed plus 2. So let me erase the previous one so it's not in our way. And I'm scrolling it a little bit up. Okay. So to graph this one, I'm going to graph the parent function of y equal to x cubed first. Y equal to x cubed. So that's the rough function, the graph of that function. You can put a few points like 0, 0, 1, 1 is on the graph. 2, 8, if that's somewhere up there, and -2, -8. But then now you are going 2 units up. On every point you have, you go 2 units up. Let's say with these 3 points, but you could have more points on the parent function. So going 2 units up, so the origin moves here. This point, going 2 units up, it's going to be somewhere here. This point, 2 units up, it's going to be somewhere here. And then the graph would look like this. So somehow parallel to the previous one. So this is going to be f of x equal to x cubed plus 2. Okay. The next problem we are doing is number 15. So you need to use transformation for this one as well. So let's just start with the parent function of cosine of x, then thinking about cosine of 2x, and then adding 1 at the end. Okay, so let's do that. I'm going to use the parent function with red. Cosine of x. So y equal to cosine of x first. Then y equal to cosine of 2x. And then at the end, going 1 unit up with blue, y equal to cosine of 2x plus 1, or 1 plus cosine of 2x, same thing. Okay, let's start with the cosine of x. Let's say from -2 pi to 2 pi. And then the increments of cosine x to be pi over 2, pi over a pi, and then 3 pi over 2 right here. And same thing with the negatives. You start with 1, And then the graph would be going down to -1, passing through the first increment, passing through the third, going up, and then same thing on the other side. This is a periodic function, so this is repeating itself. Okay. Now, for cosine of 2x, you are sort of compressing the graph, or in another word, multiplying the x values by half, because it's happening inside. So the points would look like, if this is pi over 2 on the original, and pi, and then 3 pi over 2. Now this point would move to pi over 4. This point would move to pi, and so forth. So you're just sort of compressing the graph. So your graph would start here, it would go down, then at pi over 2, you would have the -1. So, and if you tested, you would see that cosine of 2 times pi over 2, 2 times pi over 2 is pi, cosine of pi is -1. So, and you are standing at -1. Then you would have it up again, and then at pi, you are reaching 1 again. So again, since this is a periodic function, you may continue to see how the graph look like, and again, it's repeating itself. And then same thing with the other side, you are compressing because the inside is multiplied by 2, so you're basically dividing the x's by half. So be careful with the process. And then, so half of each point. So this is going to be your graph. So what you need to do now is moving it up 1. So you go up 1 unit of what you have here. So I'm going to just use the part of this period to go 1 up. You can do with every point that you have so far. So then this point will go to 2. This point will go to 2. This point will come to 1, to 0. This will go to 2. So if you think of this side of the graph, you will have it this way. Same with the other side. You are going up 1 unit everywhere. So basically, if I just look at the original, let me do it more accurate with the green. If you think of the green is going halfway here, then going down here, then up, and so forth. So now you're going 1 unit up. So and this is going to be the graph of cosine of 2x, and then added 1. So this one means up 1, and this one is, this multiplying by 2 means compressing along x-axis, and this is the parent function.